Syntax errors. These are examples of syntax errors. Misspelling keywords, forgetting to add semicolon somewhere, and obviously we all deal with these errors, but at least compiler can alert that we need to fix syntax before we can continue. Now, runtime errors are related to not checking the value before processing or using the wrong formula, but also division by zero. So, of course, division by zero cannot be predicted at compile time. It depends on input values or values that result from certain computations. And if somewhere we attempt to divide by zero, we may end up with another type of exception, a runtime exception, which is division by zero. So, for example, if we try this in our code, we can try to compute a value equals a value divided by itself, something like this, right? So, if we convert our value to an integer and it's a zero, we should be able to observe division by zero on this line of code. So let's give it a try. I'll just enter 0 as my input, and again the exception that was generated in this case, arithmetic exception and division by zero, and this resulted from this line of code. So division by zero is handled by Java runtime environment as arithmetic exception. So how would you defend yourself against this type of error? What you can do is just simply check the divisor right here. If value does not equal 0, right, we can protect ourselves from the division by zero error. So I'll just move this statement inside this if statement. Else you can give the user some kind of error message, right? So we can right here we can print print error, okay, and so forth. Or otherwise, another example of dealing with division by zero error is to again wrap a statement that could produce such error in try and catch block syntax. So we can just say let's try this, okay, and we can try this statement one more time like this, and this is the potential exception that may be generated as a result of division by zero. So here we can say that we can catch this exception, and we specify the type of exception that we're trying to catch or prevent the program from crashing, like this. So we're going to give this exception a name, and here we can handle it by whatever we do. We can print the error message and so forth. So this is another example. Like, you can sometimes use program logic to handle it, or especially if there if you have a lengthier version of computations, and you may be expecting that it could be dealing with division by zero on multiple lines, and you just want to handle it in a single place, then you can do it like this. Obviously, I duplicated my formula, but of course this could be different formulas used right here. So try block would be interrupted by as soon as there is a division by zero. So right here, when we if we run this code, okay, obviously the main program or main method executes, and we enter this try block, and as soon as Java runtime environment detects that we're just about to divide by zero, because value could be input from the keyboard as 0, the exception object is created. Okay, so we have this exception object in computer memory. The type of this object is arithmetic exception, and it also contains information about the error. So it, for instance, specifies that the error was caused by this line of code right here. And when we get to examine this exception object right here, we should be able to, so this is the reference to this object that we get in the catch statement, and we can examine what kind of error it is and so forth. So if we want to handle this error, let me just remove these extra lines to save some space. And what we can do with the exception object system.print system out print line, and we can print exception. So there is a message that explains what the error is, and we can also use this exception to print stack trace. Okay, so let's get message, right? So we can print get message, and then we can use exception itself right here, exception itself. We can use this exception to print stack trace. By default, it will be printed by on the default output device. So let's run this, and again 0. Okay, so this is now information generated by this output right here. So when we say exception get message and we print this message, this is what gets printed, division by 0. Okay, so on this line we're printing this output, and print stack trace simply shows us that in this location of our program, arithmetic exception was generated and it's division by 0. But you see that this time the program did not crash. Basically, we tried the statement. If everything gets okay, the catch statement never executes. Okay, so it's basically like, if everything is okay, just proceed forward. But otherwise, if there was some sort of exception, we use this catch block. Try and catch have to be used together, and we can handle this by using the methods available in the exception object. And we can do other things to do some error recovery. So it's not very difficult to use try and catch block. You just generally need to know what kind of exception is thrown and what to expect right here, and you have to decide how to handle your exception. Quite often I don't like to keep try and catch level of handling someplace at the high level like this main method. Instead, I prefer to create new method somewhere and do this work outside of the main method, because this is just too much detail in my view at the main method. So main method needs to do some really high level method calls and maybe handle exit condition, and this is it. But this low-level details, formulas, computations, all of this has to be moved somewhere else, possibly to a different file, to be moved out of the main method, and keep the main method as simple as possible.